let's go ahead and get started on the Chapter 4 content. You should have a copy of the book, and that's going to become increasingly important as we continue through these bash shell commands and things, because you should be starting to get somewhat familiar with the command line so that you can operate a little bit more independently. And so I'm not going to bore you to death by talking about every option of every command or really spending an enormous amount of time on each one. I'm going to give you kind of a quick run through, and I'm going to expect that you are reading the book alongside this. You can watch this video, grab your book at the same time, kind of figure out what I'm talking about and what stuff I'm kind of passing over, so you know areas that you want to kind of go back and look at again. And then you read the text, maybe work through that, and a couple of passes through it. You ought to be in pretty good shape to do the assignment and then subsequently do the quiz. Let's get started with processes. So what is a process? Well, a process is just some program that, or code that is running on the Linux system. So there are a variety of processes. There are some that are started by the system that are managing things like this windowing environment that you see in Linux Mint or whatever distribution you're using. If I launch a terminal, I'll go ahead and launch another one just for fun. So now I have two of these up, and each one of these represents a certain process. What is that process? What are we talking about? Well, I'll close that one so we're just down to one. That process is something that's called bash, which stands for the born again shell. There's a history behind the name, so if you're interested, you can look into that. But if I want to see what processes are running within this context, I use the ps command, and I see that there were two commands that are running. Each one has what's called a process ID. You see for the bash shell here, the process ID is 3540. It is also associated with a certain terminal, and that's this terminal. This is the bash terminal that is running, so it's associated with itself, that is to say with this PTS/0. This measure of time, we'll talk about what some of these stats are with PS, but basically this is how much system time or CPU time has been used. And then there's the program bash. There's another program that's running, another process that's running, and it's the PS program right here, because at the time that we executed this command, that was also operating within this context. Now there's a lot more running on this Linux system than this, but this serves as a beginning, kind of an introduction. Now, one thing that you want to be aware of is this PS command there have been different flavors of this based on their provenance, that is where they came from. The original Unix systems, Linux, of course, as you read in Chapter 1, the Linux kernel is basically architected to be an open source Unix-like replacement. Then we have the new utilities, that's GNU, the new utilities that have been added to it to give it the features of what previously had been just commercial Unix systems. So this PS command comes to us from Unix, and it has a variety of options or parameters that you can specify, and all of those have a certain format. And I really want to just call your attention to the table 4-1 that's on page 87 of the text. You'll see all of the Unix parameters here. So for example, there's this one, typing in the wrong place, PS-A, okay, and now of course I see a lot of other processes here that are being shown. I'm just scrolling up right now the list. That was PS-A. That's a Unix style parameter, okay? And back down to the bottom, so you see there's a lot of processes, and they're ordered here by default by the process number, which is roughly, not exactly always, but roughly an indication of when they were created, what order they were started in. Many of these things are, most of these things, in fact, are the things that were started up at the time that the system was launched, right? You can see here something kind of interesting. You've got here's our bash and PS that we saw before, but now we're kind of seeing most everything that's running on the system. You also see here genome terminal. That's this terminal is basically providing a window around this bash shell, so that's interesting. But there's a lot of other stuff here. I'm not sure what Cinnamon Killer does. You could look it up. Here's Cinnamon. That's our desktop environment. I'm running the Cinnamon desktop environment. If you're running one of the others, you won't see that. Mint update here, presumably that has something to do with keeping the system updated. There's more related to that. Here's a Python script, so that's interesting. There's all kinds of interesting processes running here on the system. But anyway, the table 4.1 on page 87 shows you the Unix parameters for the PS command. I don't think that's actually an exhaustive list. That's just a lot of them, but kind of some of the most common ones. So that -A, remember I typed this way, PS-A, right? As you'll see in the table, that shows all processes. So that shows everything. Okay. And there are a variety of others here. We'll have occasion to use some of them. But the thing to know is, since, as I said, the parameters that you use depend upon, which version of PS you're using and where it came from, there are some other ways to specify parameters. So go to page 89 and look at table 4.2. It continues on to page 90, and you see that we have the BSD parameters. Now, how do you know the difference between the Unix parameters and the BSD parameters? Well, the Unix parameters all start with a single dash, and the BSD parameters don't have any dashes. So now then, looking at table 4.2 at the BSD parameters, you'll see that show all processes. Lowercase a shows all processes associated with any terminal, so we'll do that, PS-A. Notice that's a much shorter list. Why? Because these are the ones that are associated with a terminal. Okay, so here's your terminal indicator. But if I want to see the list of all of them, if you look back at our PS-A using the Unix command, you see many of these have a question mark. In other words, they're not associated with a terminal. So if I want to see that, take a look down that parameter list to the 5th line in the table. And it looks like X shows all processes, even those without a terminal device assigned. So let's see what that looks like. There it is. Okay, so that's basically the same list as we got above. Although you notice the output is very slightly different. We gain this additional column here, which is stat, indicates status, which there's a pretty good description of that in the text. So those are the BSD style parameters. So which one do you want to use? Do you want to use PS-A like so, or do you want to use PSX? That is personal preference. You may use either. You can do anything that you like. Now, if this were not confusing enough, you've also got the a third option, which are the new parameters. That is GNU, again, pronounced new. Page 91, very bottom of the page, table 4.3, and spilling on to the following page, page 92. So pages 91 to 92, and you have even more options available to you. These all start with a double dash. Now, what's interesting, though, about the parameters in table 4.3, the new parameters or options to the PS command, is that they can be combined with either the Unix style or the BSD style, so you can use them together. And that's really probably the best way to think about those. Most of them, some of them kind of duplicate functionality of the others, but oftentimes with a little different flavor. But more often, you see that they actually add new functionality that can be combined. So remember, we just typed PS with the parameter X using the BSD style. I like the BSD style, frankly. My preference is to use those because I'd rather not have to type the extra character of the dash. Okay, so I like PSX, but you can choose whichever one you like, Unix style or BSD style. But now we can add one of the new options as well, called Forest, which you see adds these interesting little characters after. And this may not be terribly valuable to you yet, but let me see if I can kind of explain what's going on here. If I scroll up a little bit in this list, I see that there was a process that was started at some point called Cinnamon Session. Okay. So this is our Windows environment starting up, what's giving us our graphical user interface. And then I see these things that are under it. It looks like a little, well, this is called forest. Okay, so you can think of this really kind of being like a tree. So this is the root of the tree, and let's think about going into the smaller and smaller roots as we go down. So here's something called user/bin/SSH agent or secure shell agent. Okay, so that was started by this process. So we had this process running, and now here's another process that this process started, and here's a bunch of them that it started. And then as we go down, this particular thing, okay, Python 3, started a new process right here, and you just keep going down. You can see that again, that cinnamon session started this thing right here, which starts this, which then starts the mint update process running, etc., etc. Now, you don't have to understand what all of these things are doing, okay? If you were really digging into exactly how this Linux system boots up and exactly what things it does in what orders, then you might want to dig into such a thing. But we'll see that we'll have application for this stuff a little bit later as we go. So continuing with some interesting or helpful options for the PS command. PSL, I'm using again the BSD style options, and here we see the kind of long listing. You can think of this almost as analogous to LS with the -L option, but I can see that I get a variety of other things up here in the top. So I'll kind of explain what each one of these is for. So F just refers to certain system flags. It's really beyond the scope of our discussion. UID is the user ID who started the thing. This is the process ID, just as in the short version. This is the parent process ID. So this is what process started this process. Okay. This is a priority, and in general, smaller numbers are higher priority. Well, not in general, they are. Smaller numbers are higher priority. In this case, we see these operate at the same priority. This is called the nice value that helps in the kernel determining what priority to give different processes. This is the amount of virtual memory that is being used by the process. This is the amount of real memory that's being used by the process, so actual RAM in the system that's being used. Okay, this has something to do with the kernel function, I think, that is to be called when this process is to wake up or something like that. I really don't know that much about it. This is the status of the process. These codes mean something. We might talk about that here in a few minutes. The terminal that it's associated with, the amount of CPU time that it has consumed, and what the actual running command is. So there's actually a lot of information here. Now, if we wanted to see that for all of the processes on the system, we would just combine commands, like so. Now we combine the options. What did I type? Let me go back to the top so you can see that. Well, here, I'll just do this. PS space LX. So remember, X meant to show all the processes, even the ones that aren't assigned to a terminal device. And L gives us this long or detailed view, and so we can now see that for all of the processes that are currently running on the system. So one very, very cool utility that we have available to us to kind of have a look at processes is the top command. We'll talk about that, but first the rationale. Whenever I run this PS command, I'm seeing a snapshot of the system at the time that command runs of all the things that are running on the system. So I can see what programs are running, and I could then manipulate them from there if I need to. And more on that, on actually doing that kind of manipulation here in a few minutes. But it's only a snapshot at a certain point in time. Like, for example, you see that the PS space LX command that I issued from the command line is shown as running. Well, you know that at the time that the command prompt is given back to me down here, that command is finished running because its whole purpose is to generate this output. So this was a snapshot at the time that the PS space LX command was running. At this point, right now, it's no longer valid. We don't know how much memory processes are using, whether a process might be using more memory than it was using before. Also, if I do something like, I go down here and start the Firefox web browser, it's not going to appear in this list because that was a snapshot of before. I would have to run the command again. So now then it is the top command to the rescue. So just type top, hit enter, and now we get this display. A couple things I will point out to you. First of all, this display looks a little bit like what we get with the PS command. You'll observe that immediately. The second thing is you'll note that it's updating. In fact, it's updating about every 3 seconds. That's the default setting, at least on the version event that I installed here. Okay, so you look at it and you see that there are certain commands over here that are being listed, and the list kind of changes order. So, it's all the same stuff in here as long as something's running. There's the top command right there that is showing up in the list. Now it's not in the list anymore, right? So what's going on? Well, it's somewhere. The top, we know top is still running, right? But it's down the page. It's no longer at the top, and I can use page down, page up, or the other hotkeys. Go ahead and look at the man page for top, and you can kind of figure it out if you want to. But I can go up and down or use the arrow keys likewise to go a line at a time until I get to the very top of this. Okay. If you use your scroll wheel, then you get this, which is probably not what you want, right? But then it refreshes and comes back, so it's okay. All right, so what's going on here? Well, if you look at the CPU percentage right here, this is how much of the CPU percentage-wise is actually being used by the particular process right now. And what are Cinnamon and Xorg? That's the stuff that's providing our window interface. Those are going to take some CPU time most of the time. And so you'll see those two will tend to stay toward the top of the list when nothing else is running, okay? But what you see is the percentage of the CPU that each one is consuming. So one of them is consuming a couple percent, and there's 1%. It's kind of, things are quiet right now, and it'll pick up here in a second, right? Something else will happen. Well, okay, as soon as you say, it's like asking your pet to do a trick for somebody, right? Then nothing happens. But there's 4%, okay, so it's using a little bit more. Now then, what would happen if I launch the Firefox web browser? That might be kind of interesting, right? And let's just launch that and see how things change. Oh, now I've got 55% of the CPU, now 27 being used by Firefox. It's starting up. Now it's down to 4%. It's not using so much of it anymore, okay? It is using some memory here, but not nearly as much as our window interface is using, it seems like, right? Okay, so now Firefox isn't even, we're not doing anything with Firefox. It's basically kind of waiting for us to do something. Let's navigate to somewhere, see if we can get, yeah, now Firefox, you see, consumes more CPU and pops up to the top a little bit. Okay, and now then, of course, it's gone again. So the more active I get with this web browser, the more I'm going to tend to see it kind of at the top of the list here, because it's going to be needing resources from the CPU, or from the computer, both CPU and memory, okay? So I'm going to close that right now, and we'll see Firefox disappear from the list at the next refresh, and there it is. Okay, so it's gone now, because that process no longer exists in the system. Now, how are these sorted? You may have figured this out already. They are sorted by CPU usage. That's why the order of the list keeps changing. And so whatever is using the most is going to be the first, and the second most, the next line, etc., all the way down. This is a really good way to get kind of a quick dynamic view of what's running on the system, especially if the system is running really slowly. You say, well, something's got to be consuming all the resources, right? Oftentimes, there'll be a correlation between what's using more CPU and what's also using more memory. Either of those can result in starvation of the resources of your computer, resulting in very slow performance. Either one can. So how do you, if you wanted to see what's using the most memory, those are usually correlated, but not somewhat, but not necessarily. Okay, sometimes something could be using more memory and very little CPU. So you'd kind of like to know what the memory looks like. So what can you do? Well, you can change this display to your heart's content. Okay. Let me show you that. And so far, by the way, we've only really talked about the bottom part, the stuff below this bar. And we'll talk about this stuff in a minute, so I'll get there. But let's just talk about this view. I want to customize this. So I hit the F key to get into customization mode. And this is not the most intuitive thing. If you play around with it a little bit, you can kind of figure it out. But here's what I'll show you. The things that have an asterisk by them here, those are the things that are actually being displayed on the thing there. So I've got PID, user, priority, the nice value, virtual image, resident size, shared memory, process status, CPU usage memory, the CPU time in hundredths of a second, then the command name that's associated with it. Now then, did you want some other stuff here? You look down here, you see there's a significant amount of additional content that could be added to this. You could also take stuff off of it. Okay, so how would I do that? Well, I could use my arrow keys to navigate through these things. And notice it says, look at this part, D or space toggles display, and S sets sort. So let's toggle the display of some of these. I'll keep the process ID because, as you'll see, we're going to need that. I don't care who the user is. I don't care who the priority is. Maybe, let's know how much memory it's taking, so we'll leave those three. Process status is fine. CPU usage, memory, CPU time, command. Yeah, we'll just keep those. So I've gotten rid of user, priority, and nice just as a demonstration. The other thing I can do is use the S key to set what it's sorted by. Okay. Notice right now it says the current sort field, see it up here, is %CPU. Let me change that to percent memory. Let's say that's what I'm really interested in, is percent memory. So I'll go down there, I'll press S, and notice it just changed it up there, whose current sort field is percent mem. Okay, so there it is. Now then, what about other stuff? Maybe I want the CPU and memory stuff to be at the top, so I'll do that. And the way you do this, you navigate to the one you want using your arrow keys. Then look what it says. Right selects for move, and then enter or left commits. So I'll hit the right arrow key to select CPU usage, and then I just use the arrow keys to move it where I want it. And then how do I commit? Enter or left commits. So I'll just hit the left key. There we go. And I'll do the same thing with mem. Right, and I'll move it up where I want it. We'll put that first since that's the thing we're sorting on. Then left to commit. And when I'm done with this, all I have to do is hit the escape key. Boom. And so now I've changed my display in some way so that I'm showing the information that I might want to show. Notice now it's sorted by percent memory, which is a little more stable. Cinnamon's sitting there at 7.9% of the system memory. Xorg, that's 6.2%, and et cetera, down the list of how much memory is actually being used. And res tells me how much actual resident memory, that is to say physical memory, is actually being used, and this is showing virtual memory that's available. So now then I launch Firefox again just to see what happens here. And oh, I saw something change, right? And there it is. Firefox needs a little bit more memory. The CPU usage drops, but the memory is hanging out there at around 11.9, 12% of the system memory. I'll add another one of these, and another one, and another new tab. I start seeing it grow just a little bit. It's not a lot. Yeah, it's still back down to 11.9. It's not a lot till I start doing something, right? But in any case, get rid of Firefox, and in the next refresh, boom, there it goes, right there. So again, F gets us in there, and then escape can get us back out. Okay. So what else about top? F gets you into that sort. If I were to instead press D right here, change delay from 3.0, so you remember 3 seconds, to, let's change it to 0.5. So now I'm going to get half-second updates. You can see how quickly it's updating. These numbers are now updating once every half second approximately. Okay, that's taking more resources to do a more common update, so I wouldn't go crazy with that. 1.0 might be enough. Once every second we get an update. That gives us a little finer granularity to see what's going on. Other things that I might point out to you here in top, it's telling you the system time and how long the system has been running, how many users are actually logged into the system at this point, and the average load. This is a 1 minute average, this is a 5 minute, and check the book, but I think this is a 15 minute if I'm not mistaken. The average load over that period of time, and that would be CPU load. How many tasks are there, how many are running with each refresh, and how many are sleeping. That means that they don't have any active work to do at this time, but they're waiting for work to do. Then we've got how much CPU is being used on various things, and the crucial ones here, just to get us started, are how much is being used on user processes. That's going to be the stuff that you're actually causing to run on the system, and how much is being used by system processes. That is stuff that the operating system itself is starting up and running. So that's pretty good. Also, you get some idea of what your memory looks like on the system. This is telling us that we have around 2 million kilobytes of RAM. That is, I have 2 gigabytes set up on this virtual machine. And then here's how much is free. It's about 648,000 kilobytes. That's about, call it 650 megabytes, thereabouts, 640 megabytes of free space. So basically about 2/3 of it is being utilized in some way. We see that about half a gigabyte, or 500 megabytes, 522, is being used, and the rest of it is being used as buffer and cache space, which is an awful lot. It's just using it because it's there. If we were to start up a bunch of processes, then presumably this number would decrease while this number would increase, and we'd keep some free memory for as long as possible. So that's up. The operating system manages that. Okay, so that's sufficient, I think, for a walkthrough. But what use something like this? Well, obviously, just looking at it and staring at it, besides being very entertaining, probably isn't that helpful. But what I can do is launch another terminal window and be, doing whatever I need to do here, and I can kind of keep this up off to the side. Now, my space is a little crowded because I've kind of got it zoomed in for the sake of the video, but with a reasonable size screen, you'd have these, this off to the side somewhere, and just have it up and running and available with information for you, so you can see what's going on the system. And if the system starts really running slowly, you'd be able to gain some insight into what's causing it to run slowly, what's running that's consuming so many resources. You'd be able to gain some insight into that, and that might help you to manage your applications. It might be as simple as saying, oh, well, it's Google Chrome again, like it always is, that's taking too many resources, so let me shut that down and restart it, and maybe everything will be better. So that's it for the top command. And when we're ready, we press Q to exit. Just one more comment before we move on from the top command. Someone will say, hey, aren't there graphical tools in these operating systems that will show you the same information, kind of like Task Manager in Windows? Isn't there anything? And of course the answer is yes. Yes, there's a plethora of different tools that can show you running processes, and frankly, they're less clunky and they provide a lot more functionality, right? So why in the world do we want to use something like this? And the answer is, and I want to keep emphasizing this, you are not always going to be in a position to be able to look at a graphical user interface when you're interacting with a system. If you're interacting with a remote system, you may use a tool like Secure Shell or Telnet or something like that to access it remotely through an interface, a terminal interface that's just text, it's just characters, and all you're going to have is command line. So if all you have is command line, how are you going to get that functionality that requires a graphical user interface? Well, you're not. So for applications like that, you really need some facility with the text-based tools as well.